Anyways, so this is called side angle side. It's when we have a side and then an angle and then a side and then another triangle. We have a side, an angle, and a side, and they are congruent to one another. And then what we can say is that both these triangles are exactly the same. And so we would say that triangle A, B, C would have to be congruent, and this order matters. The parts have to match up. So what matches up with part A on this triangle over here? How do you know that? Do you see how A is between the 1 and the 3? Do you see how D is between the 1 and the 3? So angle A matches up with angle D, right? You get what I mean by that? What matches up with B? Well, B is between the 1 and the 2, right? So what's between the 1 and the 2? The E. And on the other one, the C is between the 2 and the 3. So what's between the 2 and the 3 and the other one? And so this part matches up with this part matches up with this, and this part matches up. Those are the identical spots. Now it's easy when the triangles are drawn the same exact way. You see how the triangles are drawn facing the same exact way, so it's easy to match the parts up? So what would be a good thing that we could do? What are we allowed to do, and I encourage you to do in geometry? Redraw it so that they're facing the same way by rotating it. So like if someone gave me a triangle that looked like this, right? I would take this second one and redraw it so that it looked like that. So this is A, this is B, and this is C, right? I know this has to be A here. Do you follow me? And then B was on the 2 line with the A, so this has to be B. And C was on the 1 line, so this has to be C. So now it's easier for me to match up the parts. So I like to redraw. Does that make sense? All right, so let's start using this. Are these two triangles congruent? If they are, then you need to write the triangle congruence. Yeah. Shouldn't take long. Are these two triangles congruent? Yes, no, or not enough information? Do we see how we have side and then an angle and then a side? Over here we have a side, not an angle, and then a side. This angle's in the wrong spot. So we have not enough info. Do you see how it's side and then an angle and then a side? Do you see how the angle is supposed to be smashed between the two sides? See how the side and the angle is smashed between them? You see the side and the angle's over here.
We're down there.
Now, why would I put not enough info? Well, could this be an isosceles triangle? And then would this be true? Or could it be an equilateral triangle and all of them are the same? Like, I don't have enough information to say that. Like, I can't say that they're 100% not congruent, but I don't have enough information to say 100% they are, which is what I want. So if it was going to look something like this.
It's like a really good criminal.
Are these two triangles congruent? Yes or no?
I don't think so.
Do we have a side? Do we have an angle congruent? And then do we have a side? Do we have a side? Do we have an angle? And then we have a side? So are they congruent? Yes. What would be the triangle congruency? Triangle, I'm just going to go A, B, C. What would that be congruent to over here?
Triangle.
Notice A was between the 1 tick mark and no tick mark, right? So I'm going to go over here and go, what is between the 1 tick mark and the no tick mark?
It'd be Y.
So be Y. And then B is between, well, B is the one that is where the angle is, so that has to be Z. And then the only one left is X. Does that make sense, yes or no?
Yes.
All right. What if I told you triangle MNO is congruent to triangle HIE? Just so you don't think they have to go in alphabetical order. Side MN, what would that be congruent to? Good, because the order matters there, right? What would MO would be congruent to HE? Does that make sense? And NO, what would it be congruent to? Since these are just triangles by themselves, what can I name this angle? What can I name that angle? Since it's just a triangle by itself. Yes. Why can I not call this triangle? Why can I not call this angle M anymore? How many angle M's are there? How about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. You get what I'm saying here? When can you not? No, it's not infinite. But why can't you call this one M? Because there's more than one angle that's formed at that vertice, yes? What do you notice about on the triangle that I drew over here? There's only one, so I can call this angle M. If there's more, then how do I name an angle? How many points do I have to use? 3. So angle M would be congruent to angle what? Good. Angle N would be congruent to angle. And angle O would be congruent to angle. Let's pretend like there's more. Let's pretend like we had these triangles are on like in a whole bunch of crap, so we have to name them better. So angle MON. What would that be congruent to? Angle what? HEI. 1, 2, 3, or 1, 3, 2. So then you go 1, 3, 2. You follow, yes or no? What's one of the best parts and worst parts of math? I knew that was going to be the thing you said, Brody. Okay, it can feel overwhelming. How about when we're doing something and I've taught you something, what does it now become?
Keep different. Keep learn.
Which means that I can make you access it and use that later on, correct? Do you see this parallel line? Do you see this parallel line? Yep. Do you see the arrows? So, do you guys remember seeing something like this in my class? What words should, yep, this was called a what?
Transversal.
Yep, that was called a transversal. And these angles were congruent. What were they called? Alternate exterior. These angles were congruent. What were they called? These angles were congruent. What were they called? They were called corresponding. These angles added up to 180. This one, what were they called? Same side, or they were called same side interior. That's what they were called. They're also called no. They were called consecutive interior angles. And they add up to 180. All right, well, here's the reason why we're talking about this. In this, I want to know, are these two, you guys see the two triangles? Are these two triangles congruent? And if they are, then I need a reason why. So you got to like prove it to me. Yes. Yes. Same side interior. Oh, did I say complementary? They're supplementary. They add up to 180. Sorry. What do I need right now? What do I need in order to prove two triangles are congruent? So far, the only thing I've taught you. Just literally taught it to you. We'll learn that later. The exterior angles all have to add up to 100. All right. What did I literally just teach you? What's the thing we just wrote on our papers? In order for them to be congruent, we have to have a side, angle, and then a. So right now, what do I only have? I only have a side, correct? Oh, this is probably one of the ones that we need to start seeing because it's going to happen. Do you see this side right here? That side is on both triangles, correct? Isn't it equal to itself? That's called the reflexive property. Remember that? So now what would I need? Got two sides, now what do I need? Yeah, but which angle do I need on this bottom triangle? Where does the angle have to be between, guys? It has to be angle DCA. I need that angle. And what angle would that have to be congruent to on the top one? Not A. CAB. This angle right here would have to be congruent to this angle, and then I would have side, angle, side, side, angle, side, proving that those two triangles are the same. Do you follow me? Well, do you see the line up top? This is AB. Do you see this is DC? And you see that's my AC. That's this angle and this angle. If these two lines are parallel, how come these two angles are congruent? So do I know that these two angles are congruent? Yes, I do. So what would be my reasoning why these two triangles are congruent? Because of side, angle, side. In triangle ADC, what would that be congruent to? Look at A. Where is A located? It's between the 2 and the non one, correct? So the 2 and the non one would be C for the top one. D is located between the non and the 1. The 1 and the non is B. And then the only one left has to be A. That makes sense because A, the angle is supposed to be the same as C, which that's what would happen if I had them in that same exact spot. Are you with me? Are you with me? Come on. All right, this one's long, but we're going to shorten it up. I hope this one makes sense. This is a theorem. We're going to use this all the time. We're actually going to refer to this as C, P, C, T, C. This is a huge, we use this all the time. Corresponding parts of congruent triangles are congruent. So what if I told you this triangle is congruent to this triangle? Okay? And I've actually drawn them the same exact way. If this was 3, what would be the measure of this side? Why would you know that? Because CPCTC. Because corresponding parts of congruent triangles are the same, are congruent. Do you follow, yes or no? So another way this is going to look is it might say, prove AB line segment is congruent to DE line segment. Well, first off, what do you know? All right, so you've got, if I was doing a proof, I could say that AC is congruent to what? DF, and what would be my reasoning? So what's that called? What else? Angle C is congruent to angle what? And what's the reason that is? An angle or side CB is congruent to FE. And what's the reason for that? Given. All those because they gave us those tick marks, yes? And now, because of this, I can say triangle ABC is congruent to triangle what? Remember, it matters. Where is A? Between the 1 and the not, right? So it'd be D, EF. And what would be the reasoning? Why can I say these two triangles are congruent to each other? What would be my reasoning why? SAS would be my reasoning why. And then finally, what was the thing that they asked me to prove? And I know that AB is congruent to side DE. And what would be my reasoning? CP, C, T, C. Once I prove these triangles to be the same, then their parts have to be the same. Does that kind of make sense? Yes or no? What do you think we're going to call this one? SSS congruency. Remember, these are all congruency. We're going to talk later on about something that's not. We're going to talk about something that is similarity, which is a different symbol. This is for congruency, which means these are the same exact triangles. So what is going to be happening when I have side, side, side? So it's going to be like this is equal to this is equal to this, and that is equal to that. Then what do I know? Then I know that this angle is equal to this angle is congruent to that one, and this one is congruent to that one, because then these triangles become congruent to each other once you know side, side, side.
Wait a second. So if I were to have a hexagon right here, but I wanted to show that this x is and this x is a small. Then I would do 1, 2, 3, and 1,
Right.
1, and then
Yes, you have to have a bunch of angle arc marks. Yes. How many angles are on there that you're going to say congruent? How many arc marks goes with it? Does that make sense? Yes or no? All right. You got to be careful on some of
If I
these.
were to use a megagon, I showed that all of these things, megagons are the same. I need 1 million. That would be. That would actually be.
You need a lot of angle marks. All right. What if I told you this? And this is where we're getting into old stuff that you need to remember. So I'm trying to help you activate this, but this is part of math. Are those two triangles congruent? Yes or no? Do you have enough information? Are those two triangles congruent? Yes or no? Why? I know I have a side and a side. I either need a third side or I need an angle smashed between them.
If you were to go ahead and add angles to the.
Nope, not linear pair. It's the old vocab word. What do I know about this angle right here and this angle right here? What are they called? Someone said it. They're called vertical angles. And what do we know about vertical angles? Did they tell me that information, or am I supposed to know that from my old stuff? That's how it's going to start becoming, guys. You're going to have to start. Remember how we talked about the parallels and the transversal? That wasn't this chapter. All this stuff is going to start building. That's why I tell you it's so important to know your stuff, because it builds.
I know.
So now, are these two triangles congruent? I, side, angle, side. And I would say triangle ABC is congruent to triangle what? So look, A is by the 1 and the none, correct? What is up here by the 1 and the none? E. E is by the 2 and the none, so that would be D. So D, E, and then C. Another one you need to be careful of is this one that we already did. If you're looking for sides in a triangle and I'm trying to prove that this bottom triangle is the same as this top triangle, what do I automatically know with them not even telling me? What do I automatically know? Let's call this AC. AC is the same as what? AC is the same as AC. Why? It's on both triangles. Do you see how that is on both triangles? So that's one side being congruent to itself. Do you get what I mean by that? That's one that you constantly have to use to solve these. All right, you will have homework on this. Go ahead and pack up.
I have a question.